Welcome to today's video. As the topic already says, we'll be looking at stoichiometry. So practically, we are going to be looking at what you are bound to see when it comes to stoichiometry, how to determine how to solve your questions in stoichiometry, and practically, with this introduction, any kind of stoichiometry question you see, you are always bound to be able to solve it and get the actual answer. So as usual, like, subscribe, and share so others can find this video if you do find it very helpful. So the very first thing is, what is stoichiometry? Stoichiometry is a branch of chemistry that deals with the mass and volume relationships between products and reactants. And that's why some others can call the topic mass and volume relationships, because practically it is dealing with mass and it is dealing with volume. The first and most important thing I'm going to say is right here is that when it comes to stoichiometry, one of the most important things you must do is to be able to have a balanced chemical equation. In some questions, you are given the chemical equation, it is balanced. I guess they have done half the job for you. In some other questions, it is given as a word problem, where you have to derive the chemical equation and then solve the questions. Either way, the first thing you must always do is ensure that your chemical equation is balanced. So if you are given the question, check if it is balanced. If it is not, then you balance it. If you are not given the chemical equation, then you derive a chemical equation and balance the chemical equation. It is very, very important, because without that, anything you calculate is going to be absolutely wrong. And if you should need information or you want to know how to balance chemical reactions, then check my videos. I have a playlist on that, how to balance chemical equations. All right, let's move on. When it comes to stoichiometry, we have various types, and then again, the type determines how you solve the question. So when it comes to the types of stoichiometry, we have mass to mass, practically mass to mass relationship. Always remember that your mass is in grams. So you see a question where they are asking you, what mass of this will react with this? That is mass to mass. Or you are asked, what mass of this will produce a mass of this? That is mass to mass. Or they may not just tell you mass, they may use the unit instead. You are told, how many grams of this will produce so and so grams of the other one? You are dealing with grams. That is mass to mass. And then we should note, when dealing with mass to mass, in that case, you are going to definitely need the molar mass of the substance that you are dealing with. Let's have a model equation in this case. I always like to use the reaction between hydrogen and oxygen to give water. As you can already see, this reaction is not balanced, so we are going to basically balance it. So this is what we can use to actually make our calculations. So now, what if you are told what mass of hydrogen can produce a certain mass of water? That simply means that you are dealing with hydrogen and you are dealing with water. So you are going to be using their masses, where we'll be seeing the formulas later. Mass equals the number of moles times the molar mass. However, the first thing first, you have seen the question, you know you are dealing with the masses, that is mass to mass relationship. Then the next one is, you can have mole to mole. Well, mole, the unit is always in mole. And then how do you get the number of moles? The number of moles is simply the number in front of the substance. An example here, the number of moles of hydrogen is 2. The number of moles of oxygen here is 1. There is no number behind it. And the number of moles of water here is 2. That is the number behind it. Or it is also called the stoichiometric coefficient. So if you are dealing with number of moles, you just need this number behind it. And then we can have mass to volume. So I've already said mass is already in grams. Volume can be either in decimeter cube or liters, or it can be in centimeter cube. Also note that any value in centimeter cube, if you want to convert to decimeter cube, it is simply the value in centimeter cube divided by 1000. Because in some cases, they may give you 2 different units of volume. So let's say the first value is given in centimeter cube, the next value is given in decimeter cube. So what do you have to do? You have to make sure the units are the same. So you convert one to the other. And that's practically the formula that you have there. Now, having had, these are the most popular ones anyways. However, there's one which is also called volume to volume. It is a form of stoichiometry, but you mostly find it in gas laws. And this practically is related to Gay-Lussac's law. So that's the reason why it is not really taught under stoichiometry. But still, it is still stoichiometry. But because it is used under gas laws, it is mostly taught as part of gas laws. So when we deal with gas laws, you'll be seeing volume to volume relationships. But take note that it is still stoichiometry, because what are you doing? You are studying the relationship between the volume of 2 reactants or the volume of products and how it relates to the reactants. Then we have the concept of limiting reagents. Practically, limiting reagents is referring to that reactant which is first consumed. That's practically what it's talking about. And then the opposite is excess reagents. So if one is consumed, the one that is left is called excess. It's as if you are required to cook a whole pot of rice. You are given a bag of rice to cook, but you have only a very small pot. There is plenty rice, but only a small pot. So what happens? You can only cook a small amount of rice because you have a small pot. So the pot is limiting what you can do. So after you are done cooking, the pot is going to be full. The pot is done for, but your rice is still remaining. That is now referred to as excess. Just an analogy to give you the idea of what limiting and excess reagents are. And then what you also know is that once a limiting reagent is consumed, the reaction ends. Because for a reaction to occur, you need 2 things, or more than 2, depending on the kind of reaction. But most times, you may be dealing with 2 things at a time. So you need 2 things. Now, if one is done, that means there's nothing to react anymore. The reaction comes to an end. So that's why in such questions, the first thing you do is you determine the limiting reagent, and it is that limiting reagent that determines the volume of the product. Then again, if you look at some questions, the idea is already implanted there, where you are told that one compound reacts with another compound in excess. They are practically telling you that the one that's not in excess is the limiting reagent. So practically, that is what determines whatever product that you have. But there are some questions where you are given information about both reactants and you are asked to determine the limiting reagents. We'll be having videos where we discuss that. So when it comes to volume, like I've tried to point to earlier, volume deals mostly with gases. So when it comes to gas, you can calculate it for mass. In that case, you'll be using the molar mass, or you can calculate it for volume. In that case, you'll be using the molar volume. Using our model equation, let's say you wanted to calculate for the mass of hydrogen. What you simply do is, like we said, when it comes to mass, you need the molar mass. Hydrogen, the atomic mass is 1. So the molar mass becomes, it has 2 atoms, is diatomic. 2 times 1, that is 2. So the molar mass of hydrogen becomes 2. So in this case, if you wanted the mass of hydrogen, let's just call it M of hydrogen. That will be equal to the number of moles, which is 2. Let's keep that. Times the molar mass, which is, the atomic mass is 1, times the 2, because it's diatomic. So practically in this case, the mass of hydrogen is going to be 4. 1 times 2 is 2, then 2 times 2 is 4. That's 4 grams. But what if you wanted the volume? For the volume, let's call it V of H. For the volume, again, it is the number of moles, but this time it will be times the molar volume, not the molar mass, because now you are dealing with volume. So it becomes, most times anyways, depending on the curriculum, you are either using STP or you are using ROTP. If it's STP, you'll be using 22.4. 2 times 22.4, that gives 44.8. This is in decimeter cube. So you can see, when dealing with volume, you use molar volume, but when dealing with mass, you use molar mass. That's the concept that will be needed when solving such questions. Once you understand this, it becomes easy. And then again, always remember, volume is used in reference to gases. Only to gases. Then solids and liquids, they always refer to them in terms of mass. Then for liquids, possibly the concept of concentration can also come in. And that is what leads us to the next part. What are the formulas that you need when it comes to stoichiometry? There are quite few and they are quite related, so just note them. The first one is that the mass is equal to the number of moles times the molar mass, which can be shortened to M equals N times M. Capital letter M represents molar mass, small letter m represents mass. Then like we said, what if you are dealing with volume? Volume now becomes the number of moles times the molar volume. You no longer use molar mass. That is the main difference once you are dealing with mass or you are dealing with volume. So once you know these two formulas, you are well on your way. Others you need to note, because questions can come in such formats, is the fact that concentration equals the number of moles divided by the volume. But always note that this your volume must be in dm cube. So once again, if you are given a cm cube, you have the formula right here. It is the value centimeter cube divided by 1000. So you can see that in some questions, it may be mass to mass, but you are given the number of moles. So you have to convert the number of moles to mass just by multiplying by the molar mass. And in some questions, you may be asked to calculate in moles, but you are given the mass. From here, if mass is equal to the number of moles times molar mass, then it's clear that the number of moles will be equal to the mass divided by the molar mass. So once you know these formulas, you are good to go. Then at times, they can choose to play a trick on you and use the number of, I will use atom in this case, but some can say ions, some can say molecules, and some can say entities. However, they are practically all the same thing. The number of atoms in 1 mole of any substance is always equivalent to Avogadro's number. So the number of moles in a particular substance becomes, the number of atoms in a particular substance becomes the number of moles times Avogadro's number, which can be shortened to NA, and the value is 6.02 times 10 raised to the power 23. So once you understand these concepts and you know these formulas, believe me, any question in stoichiometry, you will easily solve them. Decipher what the question is telling you to solve, what type of stoichiometry, and then you begin to solve. So watch out for further videos where we solve actual examples, applying the principles that are set in this video. Like, share, and subscribe, and see you next time.